Welcome back. And once again, my name is Corey, and this is the series where we are building a programming language from scratch in C++ using no fancy tools. Well, we're using Bison, Flex, Google Test. We'll be using ICU for the when we get to our Unicode stuff. So a few libraries, but no fancy IDEs or anything like that. Just coding in a Vim, in a SSH window or a terminal using Vim. Yeah, so we've been going through, we've got in our program, what do we have? We've got integers, we've got floats, we've got booleans, we've got parentheses for our expressions. We support all the mathematical operators, plus, minus, divide. Well, it's easier to say it like this: addition, subtraction, multiplication, division, and modulo. And we also have a boolean data type. We've got typecasting. So we've got all these different parts that we've built. And again, of course, because we're building our own programming language from scratch, if we don't write it, it doesn't exist in the language. And of course, it's compiling to a bytecode of our design, and we are executing it in a little virtual machine, dare we say, of our design. And okay, so that's fine. And I have been saying that shared pointers are too slow for this, and I stand by that statement. However, we've got a slight problem that we need to deal with, and that is that, yeah, I'll just say it that way. The slight problem is that we need. I don't want to go into extensive memory management of our AST nodes, and for that matter, I kind of like to simplify our AST nodes. That is, we've got an AST node for add, an AST node for multiply. It would be just simpler if we had an AST node for binary operators, right? Something with two arguments, and one for unary operators. That would be, well, right now we've got the minus, that's a unary operator, but also the not, the logical not, which we haven't written yet. But those, and then there's such a thing as the ternary operator. And so just if we had one object rather than right now, well, and I was thinking about this because right now we've got 5 mathematical operators, right? And we're not even talking about assignment yet, but that's a separate thing. But sorry, my brain just stopped working. So of the, again, addition, subtraction, multiplication, division, modulo, that's 5 different types, and that could be combined into one. And I was thinking about it. I was like, well, but we've also got, because we've got logical, we have a boolean, and that means we're about to be able to get comparison operators. So less than, equal to, greater than, equal to, or equal or not equal. And that would be 6 more. And I was like, but all those are really just binaries. So we're going to rewrite that to be just a single class, a binary class. But the more important thing is that we are going to use shared pointers. And shared pointers, when do they come about? Sorry, my... Now I want to know. C++ 11, yeah. I know that they didn't exist when I first started. In case you're curious, how did I know that? There, it wasn't responding to. I just, did a quick little search for it, and shared pointer, there we go, since C++ 11. It didn't exist when I started. first time to program C++, probably way back in the late 1900s. So, yeah, that's all right. So we're going to kind of jump into this. What is a shared pointer? Shared pointer is a pointer who it's like a garbage collected one, just like we have our garbage collected class. The only difference is, well, our garbage collected doesn't do it does its allocation and deallocation from our memory pool, and those were meant to work together. Whereas this is, could we use? I just realized maybe we could use our garbage collected thing and just tell it that we wanted it to be AST nodes. That might work. But okay, fine. We're going to use shared pointers. I said the reason that I had avoided them is, and yes, I've written this a couple times. This project, a programming language like this a couple times in preparation to record this video series. And one of the things I found out is that shared pointers are incredibly slow, but I was using them for the execution phase. Our computed expressions, that's where it was slow. But in this case, we're looking at using it in the AST, which is not heavy in computation. It's just, we're not passing it around through functions, right? When you pass pointers through functions, it can get really slow. And we're not going to do that except for in the construction. I think we can do this. I think we can use shared pointers for the AST nodes. And that's what we're going to be looking at. And also, we can see, by the way, we need the header memory. So we'll be pound defining memory in a lot of places. And then we're going to try to consolidate our current AST nodes, our binary classes, into a single binary. Yeah, that's the goal. Okay. And this is what we have unit tests for, to make sure that everything's still working after we have torn everything apart. Buckle up. I hate to say it. This is one of those that I'm hoping that you're interested in this to see what the refactoring process looks like, or how I'm approaching it, because we're wanting to do two things. Do I do them at the same time? Do I do one or the other? Excuse me. I think I'm going to do them at the same time, but we're just going to jump in. So first, in the make file, I know that I've got this AST node here, and why is that not copying what I just told it to copy? There we go. An AST node, and I'm going to say binary. And why is node not capitalized? I don't know. Okay. AST node binary, and this will need two new files. And so let's one here. Let's just replace the add one, or use the add one. And we will do for 51 and 52, we're going to substitute add for binary more than once. Okay, that will give us that. Now let's actually create these files, and we're going to make them as a copy the source AST node add we'll just steal that one and call it source AST node binary.cpp. Yeah. And we'll do the same thing for include AST node add and include AST node binary.cpp. All right. Now, what do we want this to be? So our include AST node binary and our source AST node binary. The include should not have the .cpp. Let me change that. Should be move. There we go. Include AST node binary. CPP should actually be called include AST node binary.hpp. That was my own mistake. Now we'll do it. Include AST node binary and our source AST node binary. Okay. It's Vim, not Vim. All right. For here, we're going to say %s everywhere where it says all caps add will be an all caps binary. There we go. Likewise, everywhere where it's ADD will become binary. Okay. Let's see what changes we need to make. First of all, by the way, I know we're going to need to include the memory header. There we go. And so this is an AST node that represents a binary expression. Now for these, they're no longer going to be pointers, but they're going to be a shared pointer to an AST node. Yeah. Okay. And everything else, and then that is going to do the same thing. Shared pointer to an AST node. All right, so the binary should be okay. The header, at least. We're going to need one more thing. We're going to need a name. We need to know which binary expression it is. And let's make it be, I want to have an enumerated inside of the class. And I'm just looking for the, I don't want enum class. I think, now I'm going to have to say, does this actually work? Do I put it under public? I know you're saying, Corey, we didn't come here to watch you figure this out. Yeah, I know. And I'm not in my quick little Googling here. I'm just seeing the enum class, which is not what I want. I want enumeration within the class. And you know what? Okay, we're just going to do this here. I don't know if it needs to be in the public or private or whatever. I'm just going to try it here, and then we can move it in a moment if we need to. So enum, and we will call this the no, I don't want to call it name, but operation, sure, and we will have add, subtract, multiply, divide, modulo. And then, as part of the, when we're creating it, the first thing is that we need to know operation op. There we go. And we will, down here, we need to store that. So we'll say performed. There we go. And this is going to be operation op. Okay. Sorry for the long pause, and I was just trying to figure that out. Now, AST node. Oh, and this one we need to do the same thing. Let's should not have done that because I don't. In the case of the compile, we're going to say if it's this one, then do this. If it's that one, then do that. Okay. So, but I do need to change. There we go. AST node binary opcode. There we go. We need it to have the opcode, not opcode, operation, I believe I called it op. And we need to add that right here. Binary. Okay. Plus, and now this is going to be messy. I don't care. We'll be fine. We'll just say, what's going to go in here? We're going to say, add then we'll say Corey, is this going to compile? That's a very good question. This is going to be ugly. You know what? I think I prefer... I need to have a nice mapping of the names. So... let's just, I'm leaving this blank. I'll come back and tackle this another time in some elegant way. But for this down here, I know we need to do switch on this op, and we'll say case add. Should work. Subtract, and this will be our opcode. Subtract. Multiply. Divide. And modulo all right. And now to make a copy, we're going to need it to be this op. And now we need to be... what's the best way to making... oh, of course. It would be a make shared of AST node. No, I don't think that that's best. Make copy, we will change that so that it returns a shared pointer. That's what we're going to do. All right, so having said that, And this, in fact, we need to change it right here. This will be a shared pointer to an AST node. There we go. And this is going to be a make shared AST node binary. And there we go. And we'll expect this make copy to return a shared pointer as well. Okay. Now, let's go into the edit the source AST node, just the base AST node. Why? Because we need this shared pointer thing in there. And for that matter, the include of the AST node. And I'm just going back to the very beginning because we don't need memory here because we're going to get it when we pound include AST node. So there we go. Memory string, blah, blah, blah. And now we're looking for make copy, and this is going to return a standard shared pointer of the type AST node. There we go. And our make a copy. Oh, don't need to use, but a shared pointer of an AST node. And it's no longer going to be a new. It's going to be a make shared AST node. There we go. Now we kind of had to do this on all of the AST nodes, which is why I wanted to do away with the existing ones. And in fact, we're going to do that. I'm going to use this other. I don't want to open the make file in the same as my C++ or .h files because I think it messes with the indentation. I may be wrong, but oh well. I'm editing the make file here. And what I'm going to do is I've got this AST node binary, and let's see. Add is gone. Boolean needs to stay. Cast, and I may do the same thing with this cast Boolean, cast float, cast integer. That is what we're doing right now. But for right now, AST node divide. Whoops, I hit the wrong. Node float, node integer. Node modulo is gone. Multiply is gone. And subtract is gone. I'll remove, well, I'll just go ahead and remove the thing. So node add. That's gone. Multiply, divide, modulo. Those are all gone. Okay. Now, what I need to do is I do need to go into each of the AST node types and have them return shared pointers to themselves. So, the easiest way, I'm starting fresh, is this, first of all, the sources for AST node and everything. No, I want to do the includes first. Always do the includes. For AST node everything, and then the source AST node and everything. And that's 28 files. Okay. But again, we're not going to need to do all of them. So this is AST node add. We don't need this one anymore. The regular AST node, we've already made that change. AST node, oh, this is the, yeah, we've already made the changes for this one. AST node binary, we've already done that one. The binary class, we've already done this with the exception of the dump. I'm going to have to turn on a fan because it's getting a little warm up here. My apologies if you, I don't know how loudly you can hear that fan. Come on. Anyway, okay, AST node Boolean, don't need that. Cast Boolean, don't need that. Cast float, nope. Cast integer. Divide, we're skipping that. Wait. We're going to have to do this again. Why? Because Corey wasn't paying attention. AST node add is going away, so we can get rid of it. Float, however, is not. And for our make copy, we need to it to be this is a shared pointer of an AST node. And this is going to be make shared of an AST node float. Okay. AST node divide is going away. Cast integer, however, we do need to change this to a shared pointer. And this is going to be a make shared. I could probably do this with a macro of some sort, but I don't know macros well enough. And is there anything else? Okay. I didn't realize this, but right here, the cast integer, this is going to also need to be a shared pointer to an AST node. There we go. Expression. And we're going to need to change all of the .h files so that, so the constructors, that's kind of the point of this, is that the expressions and everything like that are also just anywhere we were using an AST node asterisk. In fact, maybe that's one thing I can do. %s, and what are we going to change? AST node asterisk is going to be a shared PTR AST node. There we go. And in this case, it's going to be make shared cast float. There we go. That should work. Same thing here. We're going to do the yeah. Which one was the one that... The problem is this here. We need it to have a space after it. So whichever the previous file that I just closed, it's not going to work. It'll give us an error. Oh, it's not it's interpreting that. You know what? We're just gonna undo. Because I think that is correct. And then I think this one, again, this would be a macro thing. AST node Boolean. Yeah. And we've got the left-hand side and right-hand side that are shared pointers. Oh, I missed those. This is AST node binary. We had already written them, but I didn't catch the differences in the constructor. So, okay. Okay, now we're correct there. Node binary. Oh, this is the class. There. The standard AST node. Okay, it didn't exist. That means we got them all. Got them all. Okay. This one, oh, the modulo, we don't need to, yeah, because that one's going away. Multiply, going away. Negative, let's go ahead and do this one. And I think I can do this as a DW, make shared open P. Yeah, okay, that's a little faster. AST node subtract, that one's going away. Node add, that one's going away. This one subtract, it's going away. Negative, we need to make the change. Multiply is going away. Modulo is going away. Integer, we need to make the change. Float, we need to make the change. Divide is going away. Integer needs the change. Float needs the change. These should all probably become just a literal. Yeah. Well, no. They may have... Well, maybe. Strings are hard. That's kind of the problem. And they're storing a different value. So, no, I'll probably leave these all separate. Oh, well. There we go. A Boolean. This needs the change. And again, Boolean. The first one was a cast Boolean. This one is... There we go. This one is actual. That was the literal. And now... we need to just do a git grep-in for AST node that. And I want that to be a literal asterisk. Okay, so I can see in Bison, it's up at the very, very top, that in my Tang parser, I need to deal with that. So let's tackle Bison. I'm going to do this on the left-hand side, just since I don't want to lose my stuff on the right-hand side. Bison, there we go. And we know that we're going to need to move down a couple pages. This is going to be standard shared pointer to an AST node. Yeah. By the way, do we need these spaces? No, we don't. Used to, this is years ago, you could not have these touching because that was the shift right operator. And that has since been fixed, but at least I hope it has. So we've got AST node, and we're going to need AST node instead of add and subtract. We're going to need binary, and we're keeping the float, all those others, all the casts, but we're going to need to pound include memory. Yeah. And now I'm just looking for changes. So we can no longer do new AST node integer. Okay? This is a make shared and in fact up here no, I'm not going to using namespace standard this or using namespace Tang. So we're just because it's code that's being put into someone else's stuff, so we want to make sure that we are using ours or what we're expecting. Okay, for the float, you know, this could all be found with so colon %s new space Tang colon colon, and that's going to be replaced by std colon colon make shared open, and do that globally. And now we need to go back and add all of the closing parentheses. There we go. Okay, now these make shared, and this is going to be binary, and it needs oh, these don't have Tang. Okay. I think that's going to work. I tell you, I haven't tried this before we... which one is this one? Subtract. Why is that important? I don't like it where people just already done it and then they fly through the code so fast you can't follow. Nobody gets any good out of that. So this... modulo, and in so doing I forgot that, and up here I forgot the binary, AST node binary. Okay, all of those look correct. Doesn't mean it's right, it's just... The casts can all probably be made into a single class. We'll worry about that at a later time. But for right now, just we're making the big push. All right, so that's stuff in Tang. That's all in the documentation. Okay, this is node add, divide, modulo, multiply, subtract. Doesn't matter. The program. Okay, so program. That's going to be both in the include program, and we need to all right, did that. Yes, and program, it pulls an AST node, which is where it will get memory. Okay. And we also need to edit the we may not need to edit the source of program. Let's look. Add, divide, modulo. I'm looking at the bottom of the screen. Program.cpp. Yes, so there is that. Okay, so we do need to edit. Program.cpp. Did not include source. What's happening on 97? There we go. Oh, this is why. Okay. Shared pointer to an AST node. That should work fine. Okay. Now, let's see what all we broke, because this is not going to compile. I guarantee you I missed more than one thing. So, AST node.o, did I get rid of that? Shouldn't have. AST node. Oh, capital N. Yeah, I'm not sure. Not sure what I did. Oh, test dash watch. Slash AST node. Oh, I must have... There we go. Okay, now we're finally getting somewhere. Okay, when trying to build AST node, blah, blah, blah. Protected. So I have a problem in either my include for AST node or in my source AST node. Okay. So when trying to create an AST node, it needs all right, and it doesn't like it. Where am I calling this? It's wherever I'm creating it. That's where it's declared. That's where it is. It's wherever it's trying to construct one that it can't get to it. AST node CPP line 6. Oh, it's one of the things I hate about C++'s error messages. They're very, very complete, very, very verbose, and they don't tell you a thing. No, it's in here somewhere. So the AST node.cpp line 6. Oh, that's... Oh, I was streaming. It's... Is it because the way that shared pointers work? So this is when compiling AST node, so it doesn't know about any of the child classes, so it's not complaining about that. It's saying it doesn't have access to this area location. And that I know that it's got to be this line 24. I'm not seeing line 24 here. I would feel better if I did, because then I would say, okay, this is how I can find it in the future when I see this same. Oh, right there. AST_node.cpp line 24. And so it can't call the constructor. All right. That is good to know. And now what I want to say is there another way of... What do the constructors look like? That's what I want to know. And I can pull this over. In fact, let me just grab that one tab. So the I'm looking at the constructors for shared pointer. Also, so I should be able to do that. Just provide it a pointer and it go from there. So if I were to say return shared pointer of type AST node using a new AST node, question is it going to be happy? That worked. All right. Cache float has not been declared. Good. I knew I was messing up on something, and this is in source AST node cast float. Yeah, this is this is before I'd figured out the better way to do it. Okay. AST cast float. Shared pointer to an AST node called expression. Yeah. Make sure AST node cache float. That should be right, but I probably messed up the source for that. The include, sorry. Is not a direct base of. Did I mess up? Yes, I missed something. I'm still expecting the... Oh, I had to... So you should double check what you do before you close something. All right, so program. And that's in program.hpp. So that's include program.hpp line 97. I thought I fixed that. Oh wait, we should go to the top. Program.cpp. Should not delete that. Should not try to delete it. Okay, so let's go there. Program.cpp. Edit that source. Program.cpp. What line? Line 27. Why? Because it will get deleted. Now, it's a smart pointer. All right, and line 53 as well. Oh, wait. I don't need to do that. Let's see. Line 81. Oh, because the parser now needs... Oh, it's a rabbit hole. Okay, so Tang parser. How do we set these types? In the includes, there's a Tang scanner, but there's not a Tang parser. So where did we do that? We did that, I think, in Bison. It's been a while. But it's where we... Right here. It's no longer that. It's a standard shared pointer to... Okay. And no declaration matches shared pointer for get AST, and that is in 93. And that might be because in our include of program, yeah. Okay. So this is in program.cpp again. Should read this slower. Optional, shared pointer. Oh, program.cpp. Yes. That's line 93. Optional. Oh, const. Maybe that's the difference. Okay. We're making it farther. Now we're into the trouble with getting the bison stuff. So add is private within this context. Okay, fine. We can deal with that. And what this is we need to say edit. What did I say? This is the include for the AST node binary. Huh. Okay. See if that works. All of our tests pass. More importantly, I know we've changed a lot of stuff, but I'm going to say git remove source AST node add source AST node subtract source AST node add subtract multiply source AST node divide source AST node modulo, and also include AST node add include AST node subtract include AST node multiply include AST node divide, and include AST node modulo. Now make clean, make test. And why am I doing this? To show that yes, we were able to replace all those those 5 classes, 10 files with the one binary class, and all of our tests still pass. And now we've got shared pointers, which are taking care of the memory management for, so we're not leaking memory. Yeah, that's good. That's huge. And I mean, I want to do the same with some other stuff. I wanted to add I wanted to change some of the, okay. Shut up, Corey, and let's just get this done. Not going to change the others yet. I will probably do create a unary one and convert the negative to the unary. I'll do that, and that way we can have that for the not as well and combine those two. And we'll probably also do the next time we have a cast. We'll be able to do that. Why am I not combining the integer, float, Boolean, later string? Why would I not combine those into one class? The answer is because they have to contain, or they have to hold different types of data. So if it's an integer, it needs to know what integer it's holding. If it's a float, it needs to know what float it's holding. If it's a string, it needs to know what string it's holding. But for all of these binaries, the addition, it just needs the left-hand side, right-hand side. And it puts down an opcode after it says execute or compile the right-hand side, compile the left-hand side. Yeah, that's all it does. Same thing with division. Fundamentally different operations, but it's still compile the right-hand side, compile the left-hand side, put down the opcode that's particular to that. So the information that it's storing is exactly the same. So that's why we can combine them. So we won't be able to combine our literals, but we will be able to combine the unaries, and that will then make the nice pattern that for when we get to the ternary operation. We can support that very easily. But the casting is the same thing. It has an expression that it's operating on, and it's shared. So we could combine all three of those into one. So able to clean up some stuff. Now, what was I going to get back to? I'm glad you asked. The last thing that we need to do, first of all, let's look at the test .cpp, and I want to show the, well, let's do this one here. And I'm going to cout p1 dot get AST. All right. Now I already know I'm going to need to dereference it and say dump. You see this right here, what I'm wanting, when it says binary, I want to know what kind of operation it's performing. All right? That's what I want. In order to do that, we need let's just do it this way. On the left-hand side, we're going to edit. This is the binary, so I need the CPP, not source, not settings, src, the source and AST node binary. So for the dump, I'm going to say auto description equals add subtract multiply. By the way, you wonder why I keep saying it and I always use the same order? This is why. It lets me very consistently modulo. And now binary plus not opcode, op. Is it going to complain about that? Well, we're about to find out. Plus array of auto. That's fine. I can do it like this. I can say char star. String constant to char star, really? Uh, $23 doesn't like this. Expected a comma or semicolon before the return. Why? Because what did I forget? I'm famous for forgetting my semicolon. Okay. And now we've got our description, binary add. And that just took a moment for me to think through and figure out what should this look like. Let's go back to, I guess it's buffer 1, delete that, and we've got our tests. Now, before I get too far into this, you say too far? Yeah. We've deleted 12 files, and we've made a whole bunch of changes, added 2 more. I want to make sure that what I've got here is making sense. I don't see anything that just, okay, that's where I removed stuff. That's fine. Shared pointer, need the memory so we can use the shared pointers. AST node binary. Yeah. All of these make sense. All of that makes sense. Makes sense. Just looking for anything out of the ordinary, something that just doesn't look like it belongs. Okay. So I'm going to add include AST node binary and source AST node binary. And now commit everything. And we're going to say change to using shared pointers in the AST. Now, our documents. The easiest way to do this but now I'm going to need to look for something on the other screen while this is going. I guess you're probably wondering what I'm going on about. The problem is if well, you know what, here, fine. This is WSL view, docs, HTML, index. There we go. If we look at our files, we have fewer files than before. We no longer have our AST node add, for example. And that's fine. I'm all for having fewer fewer files than we had before. But git status, you'll find out there's new files, there's a lot of modifieds, and then there's going to be up here a lot of deleted files. They just don't exist anymore, but our system thinks that they should. So if I say git add docs, oh, did it add the fact that they were deleted? It's going to make a liar out of me, isn't it? Changes that could be committed. Never mind. So it got all of... Okay. Update documentation for episode. And you know me, I never remember what episode we're on. Episode 19. All right. Last thing. So we're going to tag this as episode.019 and with a message of episode.019. All right. Now, the last thing I'm going to point out is I don't want to mislead you. A lot of times I will say, hey, let's see our lines of code. I don't view the more lines of code as better. In fact, it's what I'm hoping to see today is we added functionality and flexibility by reduce the lines of code. That's what I want. And we see here that we're at 2193 total. If I git checkout episode.018, this is the last time, and make clock, you'll see today's total was 2139. Last time it was 2268, so we dropped about 130 lines, and most of that was in, I guess, C++ code, hopefully, something like that. But anyway, the point is it's not about the lines of code. And that just gives me a metric. It lets me know kind of how much work I've done, and also how well we're handling a big project. And anyway, all that to say, there we are. We're back where we should be. And the code has been pushed. And yeah, where do we go from here? Well, next time I think we're going to tackle the unary and casting, changing those over to be a single one. And then we'll add negative. I don't want to not get changes in. That is, I don't want to... for it to get too boring. But also this was an important process. That is switching this over to using, what am I trying to say? Switching this over to using a single file. Why do we need that? Because we're about to add our comparison operators, which will result in a Boolean, right? And so that is, we're going to add our less than equal to, greater than equal to, our equal to, double equal, right? Or does not equal. And we're about to add that. And so we are going to, that is, how many was that? 6? different things, plus the not, that's 7. So the choice is 7, each with a header file and a source file. We could either be adding 14 new files, or we could have done this, and now 6 of them will go in the binary one, and then the negative we're going to convert the not. We're going to convert what we currently use as the negative into a not, into a unary that will support both the negative and the not. Yes. And get more bang for our buck out of the work that we've done. So, yeah, that's it then. And as always, hey, hope it's been fun, and have a great day.